Hello, this is Michael Hendrickson, Chief Geologist of Auryn Resources, and I will be taking you through the evolution of geological and machine learning targeting at the Committee Bay Gold Project as we move closer to a discovery. I'll begin by giving you a broad overview of the project. Here you can see the major high-grade gold districts that have been defined to date in Nunavut. We have 100% ownership of a 300-kilometer-long greenstone belt that is the equivalent distance from New York to Boston to give a sense of the large-scale nature of this project. The belt is centered on the Three Bluffs deposit, which is approximately 1.3 million ounces, just shy of 8 grams per ton gold, but there's fantastic potential for new discoveries. So what are the exploration conditions at Committee Bay? Here in the video you can see the typical tundra landscape that requires exploration undercover. Basically, to find a giant deposit requires finding that needle in a haystack. Ambition, discipline, and innovation are good words to describe our approach at Committee Bay. First, we have the ambition to find a globally significant discovery, which we believe will happen in this belt of rocks. Second, we have the discipline to collect rigorous datasets that allow for high-quality targeting efforts. And thirdly, we are innovative in our approach, from developing our own in-house till sampling and assaying techniques to produce repeatable results, to bringing down the drill cost with a rotary air blast drill rig. But today we will dive into the innovation of bolstering our targeting efforts through machine learning. The question is, how does one explore 300 kilometers in the Arctic undercover? It's all about getting down to the most prospective 1% of the belt. To do that, our technical team rates and ranks the factors through each geoscience discipline we feel are the most important to form economic gold deposits. What you see here in this image is the underlying series of colored lines that produces a heat map. This is a prospectivity analysis, and it's generated by our technical team and takes into account all geological, geochemical, and geophysical datasets. Our approach previous to utilizing machine learning has led us to drill 2 gold-bearing hydrothermal systems undercover at the Ivik and Kalulik prospects, where we have intersected sub-economic grades over tens of meters. However, as a technical group, we feel that these systems have the potential to be economic based on the geological characteristics observed in the drilling. The question is, how do we find that sweet spot? And this is where machine learning comes in. We will look at the central portion of the belt where the Three Bluffs deposit and Ivik and Kalulik prospects are located to discuss our newly developed high-resolution machine learning targets. The machine learning process is valuable because it removes bias, and its in-depth analysis of our extensive high-quality datasets outreaches the capacity of the human brain. What is important to discuss first is Auryn's uniform high-quality datasets that are used as inputs into the machine learning. Simply put, garbage in equals garbage out. However, in Auryn's case, our discipline to collect rigorous high-quality datasets allows for high-quality outputs from the machine learning. And I will take you through the datasets we have collected that form the backbone of our machine learning derived targets. When we arrived at Committee Bay, the geophysical magnetics picture was regional in nature, with a core survey giving a general picture geophysically and geologically. We realized to explore undercover a more detailed survey was required, and we were able to significantly sharpen the picture not only in magnetics but also in EM data to aid in our initial targeting efforts. Here you can see the geologic framework that we had inherited in 2014 and how that was upgraded through the interpretation of the high-resolution geophysical survey. Importantly, this step defined the structural framework that are our primary target zones to host gold deposits as depicted by the black lines. Here you can see the sparse geochemical till sampling dataset that existed in the central area of the belt prior to our involvement. Our approach was to expand upon this to create a uniform coverage of the till survey across this area to clearly define each center of gold mineralization. There are also non-uniform datasets that we utilize, not only in the geologist-derived targets, but also in the machine learning process. In this case, you can see the complete rock sampling dataset that was generated over approximately 20 years of work. It is critical in any targeting approach to utilize all datasets in hand. To address the glacial cover problem, we generated a series of high-resolution superficial geology maps that define the different till and glacial fluvial cover units that define the area. These maps are based on 10 centimeter resolution drone imagery. We considered this a critical step to interpret the till and rock geochemistry results and demonstrates our holistic approach to targeting. Now that I have brought you through the evolution of Auryn's approach to targeting and collecting high-quality datasets, we can begin to address and understand the machine learning process. Why does a machine learning approach work at Committee Bay? First, we have a large district-scale land package. Second, we have uniform data collection that is high quality. And most importantly, we have our own geologic understanding of the belt that we developed over the last 4 years and now have the experience to properly evaluate the machine learning derived targets. We partnered with CompGeo Inc. to run the machine learning process at Committee Bay. They use the same neural network approach used by Google to identify nonlinear associations in the input layers that are difficult to identify in a traditional geologist-based targeting approach. So the question is, how does machine learning work? The machine learning targeting was trained using data from golden drill holes that was primarily taken from the Three Bluffs deposit. The machine randomly selects a percentage between 33 and 66% of the drill holes that contain significant gold mineralization and then analyzes the entire dataset to look for patterns that can then predict the remainder of the mineralized drill holes. After each iteration of this process, another random percentage of drill holes is selected, and this is repeated until the machine is able to predict 99% of the drill holes that contain gold mineralization. The patterns within the data that accurately predict the 99% of drill holes is then applied across the area of study to derive the machine learning targets. What you see here is geologist and machine learning derived targets on the left and right respectively. Auryn's technical team has concluded the following after comparing the machine learning targets to the geologist-derived targets. There are multiple targets derived from machine learning and geologists that overlap. The overlapping of targets gives Auryn's technical team confidence in the machine learning targets and our previous targeting efforts. In particular, the machine learning targets that are in immediate proximity to the emerging discoveries at Ivik and Kalulik have now been confirmed as future drill targets. Another outcome was that the machine learning targets indicate that the Three Bluffs deposit may extend further east and west. These targets are largely hosted in glacial fluvial cover, which mask gold responses in geochemistry, therefore previously limiting Auryn's ability to complete a thorough evaluation. The technical team will now initiate further work on these targets to advance them to drill stage and create the potential to significantly expand the Three Bluffs deposit. Machine learning targets have highlighted a 15-kilometer-long shear zone that juxtaposes green schist-grade supercrustal rocks and amphibolite-grade intrusive and gneissic rocks. This environment is a common place for gold mineralization to occur in orogenic settings around the world. This domain break provides Auryn with a third structural corridor to focus our exploration efforts, besides the trends along the Ivik-Kalulik shear zone and the Three Bluffs shear zone. Finally, machine learning has identified a number of additional targets under shallow lakes and areas of glacial fluvial sediments where it is not possible to obtain a superficial gold geochemical response. This provides the technical team with targets that may have otherwise been overlooked and opens up a number of areas for further evaluation and to potentially advance to drill stage. In summary, we are extremely pleased with the results of the machine learning targeting process for the following reasons. 1. Target areas derived from geologists and machine learning overlap, giving confidence to both approaches. 2. High-priority targets were identified immediately adjacent to our emerging Ivik and Kalulik discoveries and represent excellent drill opportunities. 3. Targets were identified in areas under shallow lakes and glacial fluvial cover that traditional geologist-derived targets would not have identified through the lack of geochemical data. Together, these factors make Auryn believe that we are closer to a significant discovery as we maximize our leverage of high-quality datasets that we have collected.